everyone. Thank you so much for joining us for Project Start, Let's Make a Cloud App with .NET. This is part one of the series. In a little bit, I will share a link to the full series so you can register for upcoming sessions, or if you're unable to stay the whole time today, you'll also be able to find the recording there in about 24 to 48 hours. Before we get started, I have just a few quick things to go over. Please take a moment to read our code of conduct. We ask that you be kind and respectful to everyone, including our speakers. We want the reactor to be a place that everyone feels welcome. Please ask questions using the YouTube or Twitch chat. We'll also be sharing some links in the chat to our reactor meetup page and monthly newsletter, as well as our survey towards the end. If you have any feedback, we would greatly appreciate that. And now I will pass it over to Sam.
Hello, everyone. I'm Sam Ronsky. I am a regional cloud advocate here at Microsoft. I work mostly in the San Francisco Bay Area to help empower people to build cool things with Azure. So what we're going to be building today is sort of the start of a longer project that we're going to be building throughout most of November. We're focusing on building something that kind of fits into a data pipeline that you might see in any sort of service that you're working on, any sort of architecture that you're working on. We have condensed it down so that the project is not a full enterprise app, because we can't do that in the 10 hours or so that we have of development time. That's a little ambitious. So what we're doing is what I'm calling matrix mesh. This is a project that is intended to sit somewhere inside of a data pipeline. It is not a full application. And so this is the architecture that we're going to be building over the next month. We have two queues on either side. One that is a request for some transformation to happen on a mesh. And then the other queue at the other end of this pipeline is the result mesh, or result queue. And so what these are intended to do is be sort of a data block or a contract location, a API boundary effectively, between our applications, the code we own, and what is everywhere else. So this is sort of intended as something that would fit into a larger organization where you would have applications publishing information into this queue and reading information coming out of it. So we're kind of sitting in the middle there. The two things that we're going to be kind of focusing on then are going to be our mesh transformation service, which is going to sit over here, and our queue handler. So we're pulling messages off of a queue. We're going to process those messages and then push them back. I'm saying mesh a lot. What we're working with is 3D mesh data. So we're going to be kind of looking at how you can do transformations, rotations, and scales on a 3D mesh. So we will get a mesh information and some operation to perform that operation and publish the result out to the queue. If you're curious what that looks like in real time, we're doing basically this. So this is a cube. If you've ever played a video game, a lot of the graphics that you see are just point data. They're points individually in space that represent different things. In this case, we just have a cube. And so each side is 4 points. They're shared on the sides. And we can translate this through space on the X, Y, and Z axis. We can rotate this like this, or we can scale it. Those are the three things that we're going to be working on. So over the course of this, we're going to be kind of poking at this and figuring out how to do this. The cool thing, it can all be done with matrices. So that's sort of the, I guess, API logic we're going to be implementing, is we're going to be implementing something that can store three-dimensional vertex data, just the points in our mesh, and also can handle four-dimensional matrix multiplication. So that sounds really complicated. We're ignoring a lot of this because, again, we have a time limit. What we're trying to do here is kind of condense this down and try to simulate as best as possible what it is to actually develop. I don't have a script with this. I do have some experience with this, but I'm also kind of coming into .NET from a infrastructure background over the past 2 years. I've done .NET stuff for about 10 years, but previously, or more recently, I've been working on tools and developer experience. So this is also sort of me learning. So I'm kind of hoping through this project, we can kind of learn together, share ideas, and kind of build something cool together. So that's sort of what we're doing. I wish I had so much knowledge. Have a Minecraft server. Would you like to help me with programming and so on? I actually run. We can actually talk about Minecraft if I have time. That's actually a separate thing, but I do actually have a whole thing about running Minecraft servers using cloud stuff. It's super cool and it works really well. But that's a separate topic. Basically, we have about 10 engineering hours for this project, which is basically a day when you talk about all the time spent streaming and figuring all of that stuff out. Basically, one day we're building an MVP that we can ship to production. So in this initial day, we have an hour allocated where we're going to be kind of walking through, setting up our project, and building things like the GitHub project. So we have a repo where we can store things. We're also going to be just building our basic projects, setting up our tests, getting really basic CI set up. And then over the next week, we're going to be adding the actual logic that is going to be happening on Tuesday. And then we're going to be adding our message queue so we can actually consume messages. That will be the first introduction of Azure, where we'll actually be adding Service Bus for those two queues. And then on Thursday, we're doing CI stuff. And so we're actually going to really invest into our CI platform and make that really nice. Maybe it's just my biases, but that's something that I really want to focus on because it makes the rest of your software better, especially when you're working in a team. Having a good, solid CI platform means that you can actually focus on your app. You don't have to worry about other people breaking the code that you want. You can actually check code in and get it published and be fairly confident that it's actually going to work. So yeah, that's that. This is Unity. We don't need that anymore. We're coming here. And this is just an empty project. We're going to be using .NET 6 for this, which was just released. You can go and grab that if you want, or grab Visual Studio 2022, which was also just released, and use that. We're going to be trying to explore as many of the new features as we can. We're not going to get through all of them. It's just not really something we can do, but we're going to try to kind of use this as an excuse to explore some of those new things that are here. So the two things that we need to create are going to be our library that I'm going to use to kind of control our mesh stuff. This doesn't need to be its own separate library. We're probably going to do that. What does the future hold for reverse engineers of games and malware? Are companies? I'm not sure about reverse engineering games and malware. Unfortunately, I'm not very sure about that. I can't help you there, unfortunately. What we're going to be kind of starting with is building this initial project. So if you're curious what versions of .NET you have, you probably have a few on your computer. So we're going to do .NET list SDKs. There we go. And these are all of the ones on my computer and where they're located. So you can actually see all the things that are installed. We have .NET 6 preview and .NET 6.0.1, which is the long-term support version of .NET SDK that was just released. So that's the one we want. It should be the default, but if it's not, you can change that with as much as you want. So .NET New, we're going to actually just start creating projects because that's sort of what we need to get started. So .NET New, let's create a class library. I think that's the right thing. If you don't know what the right thing is, let's just do .NET New list. And this is going to give us a list of all of the different things that are currently supported in .NET. Recordings are going to be published to YouTube a bit after this, so you should see recordings pop up a little bit after. These are all the projects installed for your version of .NET. These are templates that give you different projects. You can add more. You can create your own templates for .NET if you would prefer. So we're going to create a class library. So let's just do .NET New class lib name matrix mesh math. Naming is always bad for me. I'm really bad at naming. So we're just going to get started and do that. We're also going to do the important bit and actually create a Git project. So Git init creates your Git project. So you can actually start interacting with this thing and creating Git stuff. But we don't actually have a repo. So let's get that created too. So this is the new repository template for GitHub. We have my user. If you have multiple organizations, you can create them there and start publishing them into that. Repository name is what we're going to just call this. I'm going with a mono repo style. What that means is that all of our projects exist in the same repository. So in this case, our test projects and all of the different projects that we're using to manage this all exist in one Git repo. The useful part of this is if you need a change that spans multiple resources, it can be applied just in one commit. You don't need to organize and coordinate synchronizing the changes across that one thing. It should just work. So this is what we're going to do. We're going to create a public repo so you all can see it. We're not going to add any of this yet. We'll add that afterwards. So you can initialize your repo with a README, git ignore, or a license. Highly recommend that if you're new and looking to do that. Otherwise, you can just add your own. We already have a README, so we're just going to create a repo. There we go. And then GitHub is going to give us these fun commands to actually set everything up. We don't need all of this because we've kind of already done a little bit of this. So there's two things here. There's create a new repository on the command line, which is just going to actually do the git init, which we just did, add a file, commit it, and then change your branch to main. The default Git branch name is master. Current best practice is to use main. GitHub defaults to that in most cases. That's what it did here. And then add origin. GitHub is a distributed source control system. So you're going to get a whole bunch of different places for your code to live on your computer and on GitHub. A remote origin is where those other sources are. So in this case, we're pointing it to my repository, and then we're just pushing it, which is actually uploading it to that remote name, which is origin. So we should just be able to grab this, git commit. We don't need that. Let's just grab git branch. Git initialize that. We can use Visual Studio Code to check this in. Let's just check in our README. Add README. Cool. There's our thing. Let's branch that. And you will see this should rename to main. So instead of having a master branch now, we have a main branch. And then what we're going to do is actually add the remote, which is here. There you go. Awesome. Fun parts of copy and pasting. You can just copy and paste all of this. That's totally fine. I'm doing it line by line just because. So git remote add origin adds a new remote origin called origin. Origin itself is the name of the remote that you're adding. So you can name this whatever you want. Upstream is pretty typical, especially if you're forking. If you fork my project using upstream and then the URL to my repo will allow you to pull in changes from my repo. So git pull -u upstream should pull changes from my stuff. Anyway, we're going to push this. And what this does is pushes all of our code. So you can see it checks all that out. And we should now have something living out here. If we refresh this, it should all go away because we've actually hopefully done this right. Or not. What? There we go. All right, cool. Ignore this. That's a separate GitHub or Visual Studio Code plugin that does cool graphs. Anyway, there's that. Let's actually add projects now because we've done one. We have our matrix mesh math project, which is actually going to do the math. And then we also need another project, which is going to be our test project. This is actually going to run tests against the project. So .NET new, and we're going to list what we have again. What I'm looking for is XUnit. There are different testing frameworks that you can use. They do different things and have slightly different syntax, so you can choose whichever one you prefer. NUnit is the other one, and MS Test is the third option. I like XUnit because it's what I've used in the past, but we'll see. So .NET new XUnit, the name of the template we want to use, and then we'll give it a name, matrix mesh math. And then we need some way to note that it's tests. I'm just going to do .tests. Naming is hard. I'm really bad at it. So we're going to go with that. And so at this point, we now have two projects. We have one that has a class library here. And we can actually already see some of the new .NET 6 stuff. So this is file scoped namespaces that were added in C# 10, which just released in .NET 6. And what this does, if you've previously seen this, it would look like this. So this is doing more or less the same thing, except the this version is scoped to your file. So everything declared inside of this file is going to be in the namespace declared here. And so that means we just need to declare that. We don't need to extra indents or curly brackets or whatever to make this work. It just works. So we can do that. Let's do all of that. And then our other project is our unit testing project, which uses facts to define specific things that we want to find in our unit test. So the way this works is we provide assertions about what should be true about our project. And if they're not, we're going to get an error. So a really quick one is assert equals is the name. 5 is equal to 2 plus 2, which is not correct. And so if we go into our test project, so matrix mesh math tests, there we go, and do .NET test on this, it's going to run and restore our project, but also going to throw an error. .r equal. All right. Intelligence isn't working, so we're going to actually just pull up XUnit's documentation here, which I was doing just before because this is about as far as I had thought. So assert.equal, and then these two things are the XUnit solution. And so this is actually going to give us a way to actually test these things. So assert.equal. There's different things for like greater than, less than, etc. But these are just basic tests. We're trying to get this project set up and kind of build the foundation for what we're going to do next week. So we run .NET test. Hopefully, we don't get a bunch of errors. There we go. So you'll see starting test execution and then a bunch of red. The red doesn't mean it failed. Doesn't mean the build failed, but your tests did. So you can see we get a test report here, which is failed, 1 failed, 0 passed, 0 skipped, and there was a total of 1 ran over less than 1 millisecond. And it also shows you the DLL, the binary that was actually tested. And so here we can actually see what happened. Assert equals failed, where we expected 5 and we actually got 4. And there's a stack trace of what the result of that is, which is actually going to show you the line that this code is from. So we actually know exactly where our test failed. Testing is something that is super important. It's also really nice as a student, for example, if you have code that you actually need to turn in for an assignment, you can use tests to figure out if your code actually works and repeatedly rerun it so that it actually keeps showing that your thing is actually doing what you think it's supposed to do. So in this case, 2 plus 2 is not equal to 5. So we're just going to fix that, run this, and just get basic tests. We're going to kind of do this stuff a little bit more in depth and then start running after we get all of this stuff kind of laid out. So there's our tests. We have one that passes. That's good. So let's do a .NET new, and I'm going to add gitignore files to both of these. So you'll see we have a whole bunch of changes. They actually just went away. But if I go to matrix mesh test, math, there we go. Okay, lots of M's in this project. So .NET build is going to produce a whole bunch of files in the build. So we now have 27 files that are built, including like the binary of the thing at that thing, and caches and all sorts of information that we really don't want checked into our source control most of the time. So gitignores say ignore these files. .NET comes with a template that just adds them for you. If you don't want to use that, you can use GitHub's templates. GitHub has different templates for each specific project. So you can just go and search those and find which template to use for your project. .NET's just works, so we're going to use that. Git ignore, and you should see all of these things go away. And now we just have the source files for both of the projects we have. We have the CS project files, which is just defining what is actually in our thing. This is our changes, so that's a little bit less useful because there wasn't any changes. It's just a new file. And so the project file is just defining what framework are we targeting. You can change this to do like .NET 5. It would fail because we're using .NET 6 features. And there's a number of other things that you can do. What else? I think that's mostly it. You get a git ignore, which ignores a whole bunch of things. It's fine if there's extra stuff in here. This is just, again, a generated template that targets a lot of files that are going to be generated for all kinds of different .NET projects. So not all of these are going to exist in our project or in your project. So there we go. But this gives us enough so we have a little bit more focus on what we can actually check in. So we don't need to commit a bunch of binaries and things and just kind of make our Git repo really big because that binary is going to change every time we build, which means every time you try to check something in or anytime you try to check something out and you've been working on your project, you're going to have a conflict. If you check in those binaries and then two people start working on the project and one checks in their new binaries and then you try to check in your files, they're not going to line up and your history is not in line. There were two people working in tandem, and so those changes don't actually align with one another. You're going to get two sets of changes that don't really work. And then that just, then you're trying to merge binary files, and it really, why? So this gets rid of that hassle for you. So highly recommend doing that. Anyway, that was fun. So we have both of these added. Let's add matrix, mesh, math. Still lots of ends. That's fine. And tests. Cool. This is going to check in our two projects. We can upload this. Clicking that button on Visual Studio Code is just going to synchronize things, which means it's going to pull down any new changes from the main branch and push other new changes. The other thing we want to do is add some quick CI to this. We're doing a lot more. We're going into this in depth a little bit on next week. But for now, we want something that just kind of says, yes, this still builds when you try to commit code to it. It also means we've been checking directly into main. It means we probably want to switch off of that. For now, I'm still getting everything set up. So we're just going to go right to main. And then this will kind of kick us off of this project to something else. So let's figure out how to do that. So for me, I don't actually remember how to do a lot of these. I have notes or GitHub Actions syntax. You can just look up what to do. So this is the syntax for GitHub of GitHub Actions, which trigger on different events. We can just go here, grab the event name, and work from there. So what we need is some YAML in .github/workflows, which is right here. And so we're going to create that. And again, we're going to be really investing into CI in a bit. So right now, what I'm focusing on is just getting this all working, just so we have some notion that things are working. So tests pass and our code builds. Those are like the two things that I'm focusing on right now, just to kind of get us started. So GitHub/workflows. There we go. Create our workflow. And now what else do we need? GitHub/workflows. We have our name. We have a trigger, which is on push or pull request. That's probably what we want. So let's just grab that. And then the name for this doesn't matter. So we can call this pull request. YAML. Oh. On pull or push or pull. We just want this on pull requests to our main branch, which I don't remember how to do. So we're just going to hope that we have a little bit of handholding. I'm using a GitHub extension in Visual Studio Code, which gives some help for this syntax that actually kind of helps you figure out what you're doing. It actually hints at a lot of the syntax that I was just looking up. So in this case, we're going to do a validate pull request on pull requests like this. The syntax changes here because I actually want a little bit more information here. We want, I think it's branch something. All right, no help there. Cool. So let's go and figure out how to do this. On pull request, branches main. There we go. Cool. Right there. Perfect. All right, so our syntax highlighting. Grab all of that. We have our name. And everything should be good. So what this is going to do is when we create a pull request to our main branch, we're going to run whatever this is, which we haven't defined yet. It should just work. So we have all of that. That's all of the stuff for our triggers. The trigger is just whenever a pull request is created to main. I'm targeting specifically main so that there aren't checks that might get run if you are creating a pull request into something else. Maybe you want to do that. I don't, so we're just ignoring that. So jobs, job ID, let's just grab these. Jobs in GitHub Actions are just things that run. These run concurrently if you define multiple of them. So in this case, the sample is going to have 2 jobs that execute simultaneously whenever there's a pull request to main. We don't need the second one. So we're just going to call this test. Sure. And so this will be our tests. Property runs on. Where does that go? So we're getting an error that we need runs on defined here. Runs on is going to define what environment this job runs on, which we need right here. So runs on, and we're just going to pick Ubuntu latest. We're going to be targeting Linux environments here, so we're going to be just aiming for Linux. If you want to target Mac or Windows, those are both options as well. But again, we're just targeting Linux stuff, so that's where we're going to put it. Ubuntu latest, and we actually get some hints here. I've showed this previously, but these definitions, Ubuntu latest and Ubuntu 18.04 and 20.04 are defined by GitHub. So you can actually go and look up what these images are. I don't see virtual environments for GitHub. There we go. Then we might be going down a rabbit hole. Let's just go to GitHub. So we can actually go and grab our Ubuntu. Let's do this. GitHub Actions, Ubuntu 20.04 virtual machine. So GitHub Actions run on virtual machines that have different definitions. They have a lot of things installed for you already. So what I'm checking is whether it has .NET 6 installed or whether it doesn't, because I actually don't know. So that's what we're going to try to figure out here. We want Ubuntu 20.04. This should be our latest, if I'm correct. Yeah, Ubuntu latest, you can see this is the label. Latest just means it's going to automatically update with you. If you want a stricter version, choose an actual one. So choose Ubuntu 20.04. Otherwise, the latest version is actually going to update over time to whatever the next latest thing is. So in this case, there's a whole bunch of things. Let's look for .NET. .NET Core, it goes up to 5, so .NET 5. So that is not going to work for us. We actually need .NET 6. So I need to figure out how to install .NET 6 because that's the next thing we need to do. So let's go and figure out where that is. So GitHub Actions, install .NET. Sure. So here we go. Different actions to install and build .NET. Setup.NET, I believe, is the action we want. So there we go. Setup.NET is, yeah. So there's for different languages, there's actually a pretty standard like setup foo, whatever the language is. In this case, it's .NET, to actually install the version of .NET that we want. So I think this should just work. Again, we're doing this relatively just unscripted and live, so I don't actually know. I don't know if this works yet or not. I haven't tried it. So that's sort of the point of this, is kind of showing how I go about solving these and talking through as much of it as possible. So again, I would encourage questions. If you have questions or suggestions about things we can do, look into, explore. That's sort of the point of this, is to kind of give us that opportunity to dive into all these things. So runs on Ubuntu latest. What? Tests. I have screwed something up. Jobs. This. Our syntax is not working. So I have steps. The name is steps. There's supposed to be steps. All right, cool. That explains so much. Steps. Awesome. So each job in GitHub Actions has a series of steps. Where jobs are run concurrently, steps are run in sequence, which means this is an ordered list of the things we want to do. The first thing I have it doing is checking or setting up .NET. That's actually not usually how you want to start these things. There's another one we want, which is actually going to check things out. So we actually have this here, so let's just use it. And we're just going to say uses actions checkout. What that action does is a pretty standard thing. It checks out the code at whatever current reference you're at. So it actually pulls the current version of the code according to wherever this code is in your repository. And so this is going to set up our GitHub Actions. That demo was using a matrix so they could install different versions of .NET. We don't need that. We're just using one. Because for libraries, it might be useful to target different versions of .NET. We're using .NET 6 features, so I don't really know if that's going to work. But also, we're targeting .NET 6 for our internal application. So we don't need to be as permissive, I guess, in the versions of .NET that we support. So let's do this and plug this in here. .NET 6. And .x should just be a wildcard to pull whichever version makes sense. And don't know if this is going to work. Haven't tried it. So let's grab a few more things. I want to, this actually looks fine. So we're going to actually not quite copy this, but we're going to install dependencies to .NET Restore and then run .NET Test to test the project. And that should be it. So let's do that. Really did install dependencies, and I'm just going to rewrite it. But anyway, install dependencies. To say restore .NET packages. We're restoring our packages of whatever it is. We're eventually going to be adding a bunch of different things. So this gives us a way to actually restore those and make sure they're available. Why doesn't it like this? Nested mappings are not allowed. Okay. Oh, that's why. Name is something else. Anyway, we're just going to run .NET Restore. There we go. Easy. And then the next thing we want is .NET Test. But we actually need to target the specific project we're running this against because we don't know. In this case, we're trying to run tests. So I'm actually going to navigate into our test directory. So we should be able to do, never tried this, so we're just going to try it and see what happens. Matrix mesh math.tests. And that's going to move us into our testing directory. And then I'm going to do some fun YAML stuff. So that bar creates a multi-line string in YAML, which I think will work. Maybe I need to remember bash, and I don't remember bash. So this might be a bad idea. Implicit keys need to be on a single line. We'll try it. This might blow up in my face, but that's fine. We're just going to see if this happens. But what this should do is navigate into our matrix mesh math tests project, and then do a .NET restore and a .NET test. I'm pretty sure this is going to throw a bunch of errors. We might need some new lines. So this is a break to tell Bash to ignore the new line, so we can actually send multiple commands. Because we're running on Ubuntu, these are going to be targeting that Linux environment. So PowerShell or something isn't going to work here. So let's see what happens. This is set to go on pull requests. I'm going to add on push quickly. No arguments there. Just on any push, run this command. I find this really useful when iterating over things to kind of test how this is going. If you're doing this on an actual public project that other people are contributing to, you probably want to say push to whatever branch. Like spam dev, for example, might make sense. And we can actually, let's just do that. So let's create a new branch called sam dev. So we create a new branch. We're going to be targeting just that branch. I don't know. Oh, all right. It's just saying incorrect type. Pretty sure it's fine. We can add quotes if we really. Oh, I guess YAML's weird. So anyway, we're going to target just our branch. What this does is it prevents you from breaking a whole bunch of things if you're working in a team project while still doing some slightly hacky things. So this gives us a way to kind of iterate on this in our own dev branch for changes to this process. It's not perfect, but it's better than just contributing a bunch to the main branch, because these can be squashed down eventually, and you can remove a bunch of your work. So let's check this in and see what happens. Initial GitHub action. And so this should create a GitHub action for us. We can publish this. Clicking that is actually going to publish our branch up into our repo. There might be a few other steps. If you're working in a team project, you might be working on a fork, in which case you actually need to push to your fork and then make a pull request into the project. Because we push directly to the project that already existed, it should just run. It should be running right now. So let's do GitHub com matrix mesh. There we go. And so our branch has new things pushed to it. If we look at actions, it failed. And now we get to figure out why. I have an error in my YAML. Oh no. All right, so line 21 makes sense. Okay, so what I thought would happen happened. I don't see an example here of doing multi-line runs. Quickly just scanning. No. Okay. Just double checking to see if that actually existed, because it would be nice if there's just a quick example there. This is a random piece of documentation, so we're kind of in the weeds, but that's fine. We can fix it. So let's just do that. The easiest way to do this is going to be with multiple runs. Part of this entire process is taking out technical debt. That is not a bad thing. You can't make things perfectly, and a lot of time technical debt just accrues over time regardless, because it's not just quick things that you've changed to your code, like shortcuts that you've taken, or in this case 3 run statements when you could probably write 1 in some case. It can also be the business changes. Whatever you built your app to solve isn't exactly what you need to solve anymore. There's something new, or the problem has changed, and that can also introduce not really technical debt, but technical debt, which is really just like your solution not lining up with the problem you're trying to solve in the best way. At least that's how I think about it. I don't know if that's the best answer there, but that's my thought process. So let's fix pull request. And I'm curious if we're going to get another. The cool thing, setup.net did not fail. So we should have pulled .NET 6, which is good. I'm going to synchronize these, send these changes back up to GitHub. If you notice that your changes are not being run in your action, you probably haven't synchronized them. There's 2 steps that need to happen. Because Git has a distributed files or distributed source control system, committing your changes only affects your local changes. So you can iterate on your source locally and even completely change it locally, but you can't, but they don't get reflected publicly in whatever other repository you're pointing at unless you do this. .NET Restore failed. Specify project. Okay, so I think the run is what's failing here. So let's figure out how to actually do this run correctly because I should know this. GitHub Actions multi-line run. So let's find this. That looks fine. That should be good. So I was almost correct, it looks like. Yeah, all right, cool. So let's go back to this. And we are making a bit of a mess in our source control. That is fine. We can fix that. And that's sort of actually helping us because it's actually something that is going to happen all the time. So this should hopefully create our multi-line run. Why doesn't it? I think that's fine. I don't think that's actually an error. I could be wrong. But anyway, fix again. At this point, the commit messages do not matter. We're just committing code into GitHub to test this thing. And so what that is actually intended to do is just kind of get us to the point where this works. And then because we're committing to our own separate branch, and this isn't in the main branch, which everybody else on the team would be using, what we can do is actually go and squash all the changes down into just one. So instead of all these commits that aren't very useful in history, we can have just the one commit that is actually adding the GitHub action. So one of the cool things with Git is you can go and rewrite history. And it's broken again. Same issue as before. Error in your YAML syntax on line 21. I thought I looked at this correctly, and I clearly didn't. Workflow syntax. Run. Defaults run. Let's go find steps.run. I don't need the slash at all. Okay. Wow. There we go. It's right in the documentation. I should have just read that. Awesome. Perfect. Okay, cool. So what we're doing here is actually navigating into our test project. We could just give the name of the project to use. That actually might be easier. So .NET Restore name. That's not what I wanted. Help. There we go. And we want to figure out how we can provide a project or a solution to restore. So matrix, mesh, math, tests. And we should just be able to repeat this here. And now we don't need that. It should just work. I've said that before. So we'll see what happens. So let's update our pull request again. And again, there we go. And I'm pretty sure this should work. I don't. Maybe I'm making a mistake ignoring the big red line, but nope. Okay, I'm making a big mistake ignoring the big red line. All right, cool. Great. You haven't had a syntax error? Error. What? Okay, cool. I'm lost. That's perfect. Kind of doing exactly what we intended with this entire process. Though I didn't expect to hit it here. I'm a little confused with why. Why this is not doing what I thought it would do. That's odd. Unless, no, oh. YAML is weird. Pretty sure that just fixed it. So we're just going to, with white space. So YAML is white space sensitive, and I'm pretty sure mine was wrong. So that's fun. I think that should be everything that we need in order to fix this, which if it is, oops, but also that is absolutely something that is going to happen all the time. So perfect. I'm actually kind of glad that we saw that because it seems like it's working. So we should be able to actually see some of the things start running here. Basically what this is going to do is run tests and fail if the tests don't work. So we should be able to get this checked in. And the final thing we can kind of run through is just like, let's build a test, or let's build something that fails our tests so that we know this entire process works. It succeeded. In this case, the succeed or fail is actually based on the exit code of the commands that you're running. So in this case, we have .NET test running, which is actually going to return a number code that represents the status of when it exited. 0 is successful. It means it exited fine. Anything else is an error. They can mean different things for different programs. And you can check that with, I think it's like $? Or something like that. Actually, it's different in PowerShell, but I think that's true. All right, cool, I think. Let's do something that won't work. .NET, this doesn't work. Okay, we get a whole bunch of things. My shell actually tells me that we got a bad error code, but if we do $? Or $? There we go, we get false. So there was an error. And so this can be useful to tell different things about the status of what's happening. In this case, it's telling us that our tests failed. So our tests don't work, we're going to get an error. So before we do anything, we're actually going to remove our push here, which we're going to do git commit. That's what we want. Run basic tests. Sure. So this is just going to run really quick tests against our project. When this happens, just pulls the new things for the test, runs those. That's fine. We're expanding this on Wednesday, so we'll go and actually like really look at Wednesday, Thursday, one of the days next week to actually make this really nice. But right now, we're just trying to like get everything set up so that other people could contribute to this project. There's sort of a series of things you kind of want to do to just get everything set up. I like to have CI working because I feel like that's sort of a necessity in a large team project, especially after you get over like 2 or 3 developers. Just the communication and making sure everything is going to work and coordinating work just gets way easier if you have CI to double check that. And deploying gets way easier too, which we'll get into later. There's some cool deployment stuff we're going to get into. So I think that's everything. It should be checked in. So before we do all of this fun thing, there's a series of commits here, which aren't helpful at all. So we have run basic tests with white space again, fix pull requests. None of those are actually useful. So what we're going to do is actually rebase this and get rid of all of those. Cool thing, GitHub will do this for you. So we don't need to fix this ourselves necessarily. What this is going to do is if we do compare and pull request, this is going to show what branch we're on. So Sam dev, and we're pulling this into main, which is the main branch where we're merging this into. This is also the same process for contributing from a fork, which is typically if you're considering working with open source, this is going to become fairly familiar as well. So add GitHub action test on pull request. So we're just going to add something that's actually useful and create a pull request. Now you can see there's 6 things here, which aren't very useful. And you'll also see GitHub Actions runs based off of the state of your current project. So the current branch. So this means if you update tests or the process in this case, it's going to get run. Because we have a definition for a pull request that should get run when you're checking this code in, it's running. And so we can actually see this check is running and is actually being executed. So once this succeeds, we should get some good information here. So we have one pull request open. You can see the checks have passed. And we now have all green. You can show all the checks. If you have multiple GitHub Actions, they're all going to be listed here. And you can go and explore which ones failed. This is also why it's important to give good names for your actions, because they show up here. And so if one of these starts failing and it's just GitHub action, nobody's going to know what's failing. And so one of the bigger things, especially with tests, is to actually describe and point directly at the broken bit, because just getting a compile error is not very useful if you don't know what line broke and why. So there's that. That should at least validate that that project builds and that project has succeeding tests. So we should be good to merge. This doesn't actually ensure that the tests will pass in the main branch, though, because other work can happen in main that may conflict with some of the work that's happening here. You may get a conflict and it may not work. But this is good enough for us for now, and probably for a very long time. Again, we have limited time, and we're kind of introducing things here. So we have all of this. The default is going to be a merge pull request. So we can actually switch that to squash and merge. So what this will do is it's going to combine all 6 of those commits that we made into just one, which means that you have, ideally in your source control, a history of commits that are actual changes to the code, not just like an hour of your work, but actual features or actual like items from your feature list that are actually being delivered. So you actually know which code did that, and you have the entire change in one place. Which means it's really easy to revert if something goes wrong and it doesn't work. It also means it's really nice if you want to figure out what a change was, because if in this case, we're only changing one file. If we're changing a whole bunch of files, we do some refactor or something, and they're across multiple commits, it's hard without going to a PR, which is a GitHub thing. Without going to that, it can be difficult to actually tell what any of this means. So in this case, we're going to squash and merge. And this is actually going to give us the name of the commit that it's going to create. So add GitHub action test on pull request, and it automatically appends number 1, which is the number of the pull request that is created here. The other things that it's doing is specifying all of the commits here. So if you're squashing a bunch of commits and your commit messages are actually useful, they're preserved here. Ours aren't useful because we're just testing a GitHub action. So what we can do here is just kind of wrap everything up and remove all of that. It doesn't need to exist there. It will all of this history is still going to exist on the branch that we developed on, but it's not going to exist on our merged copy. So what do we want to run? Matrix mesh math.tests on a pull request to main. Sure, so something useful. So we're going to squash and merge, and we could also delete our branch to kind of clean things up. Especially if you're working on a project for a long time, highly recommend doing that. You can also automate that so it all goes away. Same with the squash and merge, which we're going to turn on in just a bit. But this is, again, project setup stuff, and we just got the final piece done for us to actually wrap all of this into a nice-ish tie and kind of finish this up for today. So our changes are there, and you can see we have our new commit. If we look at our history, there's only 3 commits. So all of those extra commits are gone, and we just have a really clean history that's pretty much add a README, add the projects, and add a GitHub action. And so highly recommend doing this because it just makes this a lot easier. And it means when you're doing a release, you actually have a list of things that are in the release rather than whatever else they mean. We're going to kind of aim for something that is continuous delivery. So less important there, but still Nice. So we have about 5 minutes left. If there's any questions or comments or anything that people have, feel free to drop them. Otherwise, we're going to really kind of start implementing a bunch of stuff next week. Just for now, doing some settings things, just to kind of finish setting up this project. We want to protect our default branch. So we're going to branch protection rules to disable force pushing, prevent branches from being deleted, and so on. So our default branch is main. We're going to add a rule for main that requires a pull request before merging. So this is going to prevent directly contributing to things. We can also require that code owners have to approve. So if you have some team lead or something, you can make sure that they have to be the ones approving that. It's just me, so we're fine there. There's no other contributors, so I'm kind of tweaking this specifically for this project. We do require one approval, and that should be enough. So we can just create this. And never mind, I need to confirm my password. I will do that offline, but basically you just need to enter your password and do that. And that would protect your branch from a bunch of things and prevent other team members from pushing directly to main. That's important because what we're aiming for is that main represents the code that is in our production server. And so if you can push directly to main, that means you can immediately launch code into production, which we don't want because it isn't going to go through testing. It isn't going to go through a bunch of other things. We might still run a few tests on it, but you want somebody else to be able to say, yes, this is okay, before code just starts going into production. It prevents a whole bunch of issues and hopefully keeps things a little stable. And so in that case, we want something like this just to kind of prevent that, especially since we're targeting continuous deployment stuff. We're going to eventually have our infrastructure defined in this repository with more C# codes. You can actually write C# to create an Azure service. That's coming in a few weeks, actually. But anyway, I think that's mostly it for just getting everything set up. We have 2 projects. We have our test thing. The next thing we need to create is actually a queue service that can actually pull this in, and a web service. Both of those should be pretty quick. Most of the actual work is being done inside of this new library we created, and we'll do that on Tuesday. Thank you so much, everybody, for joining me, and hopefully this is a fun project that we can kind of explore and expand on and learn some things from. So I hope that was helpful, and I will see you next week.